My name is Mihaela Ghidersa. I'm a software developer at Centric Romania, and besides my deeply interest in software and technology, I also like to prepare presentations and trainings for amazing events like this one today. So thank you to the organizers for having me and for actually allowing me to discuss with you today. When I'm not speaking or coding whatsoever, I like to dance, sing, read, travel, just your typical developer. A bit of insight about my activities. I am a developer at Centric Romania, as I said. I also like to organize events for the Yash Software Craftsmanship community. Also, I am part of the team that organizes events for the girls that want to go in the IT area and want to develop on this part. And because I like to speak, I'm also a member of Toastmasters Yash. Today I want to invite you to join me in a talk about a subject that's been very painful to me, at least in the last 1.5 years, and I'm still searching for the best approach. But, as you already can notice, I want to discuss concepts and approaches, and most of them are from my experience or projects that I had near me. But I'm extremely interested in your experiences also. I deeply think that we can add up to this presentation and do a two-way knowledge sharing, so let's get it on. Working in distributed teams is hard. On one side we have the backend developers, on the other side is front-end developers. Well, when it comes to collaboration, it's not always easy, but we do have some things that we talk about when we encounter issues, and we are always asking like, okay, why can those backend developers just give us what we want? Yeah, because we always expect the best part of their work to be done in order to fulfill our needs. Or why is it so hard to work on the backend part? Or how hard it is to build a backend that just fulfills my needs? On the other side, the backend developers are just thinking, what is happening with the front-end developers? They are just moving pixels around and just displaying data, so what it is so hard? So it's really hard to actually understand each other and work together, especially if we don't have a background in the full-stack development. But before digging in, I have to tell you something. Before being a more oriented front-end developer, I used to do full-stack development. So I will take the liberty to talk for both parts today, because I know what they say about each other. Usually, working in a distributed team can be frustrating. Well, unless you are creating both front-end and back-end, discussions about the data use, performance, or inconsistencies appear all the time, we like it or not. So this takes us to talk behind each other's backs, as we just discussed. The thing is that where all this started, the feeling was that the backend developers have always done the more smart and serious programming, thinking about meaningful issues such as testability, maintainability, state management, API design, and whatsoever, while the front end played with pixels and just made things look pretty. The reality is that JavaScript has absolutely exploded in the last years, and a lot of the responsibility went from the backend part to the front-end part also. If in the beginning we had to, indeed, deal with some specific pillars in the web development, such as HTML, CSS, JavaScript, some preprocessors language, now everything got way more complex. We now think about the same problems in the front end as in the back end. These separations are not longer valid. The issues we talked about before as being perceived back-end matters, and we just said about them, persistence on the state management, maintainability, API design, are now the daily debate and work of client-side developers. So today, we are talking about the application, the development team, but specifically, we talk about workflow and responsibilities in distributed teams. As a result of what we've talked before, when we talk about data that we receive from the server, our client ends up managing too much. Is it? You know who will suffer from this? Front-end developers that will become very frustrated from not being able to manage the code base anymore. Also, the need for refactoring appears way too often in order to gain some control back. This also brings serious complications on the performance side. And you know who can be happy about this? Users. So let's go from the beginning, the place where the chaos began. Everything started with the sentence, I need some additional data in the interface. And everyone would just, oh my god, what are we going to do about it? Who is going to do what? Maybe the backend developers said the front-end developers, maybe the front-end developers said the backend developers. Well, the full-stack developers try to make everyone happy. So they come with a couple of ideas. Let's just create a new endpoint and use it. Or let's just add more data to the endpoint that we are already calling. Yes, it's a good idea to create a new endpoint and use it. Seems nothing harmful about it, because our application makes 2 calls over the network instead of 1, and it's for a certain action. But what happens when this is done in a regular basis? Just add more 3 to 4 times of repeating this scenario, and your app will end up with anything but something called performance. This is called chattiness. This kind of mindset usually ends up with a lot of complex business and adapter operations on the client. I would know, I've been there, I try to deal with that. And besides, complexity on the front-end code base, it's not something that we want. The other option that we have is, okay, let's just add more data to the endpoint we are already calling. Yes, you can collaborate and say, okay, this time I need 2 more properties, what can go wrong? Another time you are like, okay, just give me 3 more, what can go wrong? But if you repeat this process again and again, it becomes a problem again, because endpoints start to return more and more stuff. Sometimes even different clients are just calling the same endpoint with slightly different data and end up with a lot of bloated results. These are called fat payloads. You've probably heard about this before. So you have to be very careful when it is the case for any of these 2 situations to appear. Unless is another solution, or maybe something that we've been working on the way. Well, we've worked with endpoint APIs for so long, and they work great when it comes to provide data to the client for clear, specific use cases. But while development in the client area went crazy in the last years, the server had to fulfill more complicated scenarios. This is how we end up with APIs to answer 2 main use cases. Yeah, even the 2 options that we've already discussed are actually leading to this. These sort of APIs are also called the one-size-fits-all API. And this kind of APIs are messy and hard to maintain, and usually make us blame REST. But it's not about REST, it's about the architecture and approach we are using when designing those APIs. Another issue that the 2 points that we've just discussed brings is, okay, let's say that maybe we thought about switching to a microservices architecture and let go of the monolith. And of course, time showed that there are a lot of benefits in this area, but there is one specific thing that, although it might not seem that important, might bring a lot of trouble to the front-end developers. With this approach, the client has to consume data from several different sources. It had to shape it to fit the requirements. But would this mean that the client is now responsible for the complexity? Is it something that we want to bring some complexity in the front end? Or this is something that actually is a characteristic of great APIs to actually deal with that complexity? So for a second time, is it something that we can do about it? Because Yes, at this moment, it's natural to feel a bit stuck. We are driven to some constraints we hardly have control over. But how about we change perspective for a second? Look at the advantages. We, as front-end developer, are the closest to the users and the ones that provide interface to the users, the one that they work with. So why don't we just take more responsibility on the overall application? Would it sound crazy for front-end developers to build some own servers? Well, the answer to this question is going to be discovered today together, and mostly by you, because you know your use cases better than I do. But I want to invite you to actually talk about Backend-For-Frontend pattern, GraphQL as a solution, and maybe see if they can work together, if there are some cases that work very good together in this area. So we are going to start with the Backend-For-Frontend part. Well, first, let's talk a bit of history. First production and popular approach of this kind, it was presented by Netflix because they had to do a very big redesign of APIs in 2012. In a post they made related to the change, they written something like this, that they found some very important limitations in the traditional one-size-fits-all, the REST APIs approach. And as a result to that, they decided to move to a new, fully easy-to-manage API. So they started from the reality that they had something like 800 different services. And it's not easy to actually create a fallback for each and every single different device like this, with some very specific use cases, with some very specific requirements. So the most effective solution seemed creating a new concept, some sort of layer between the client and the server. And very important about this layer was that it had client-specific code. And this was something that actually made a lot of people think about, okay, how this is going to work with the architecture, where is it going to fit? Well, in this way, the server code just takes care of gathering the content, while the adapter layer just aggregates and modulates this data in this client in the way that the client wants it, so in a specific client way. So in other words, this gives back some control to client developers and allows them to build their own client adapters on the server. Another case like this, it was at SoundCloud. While migrating from a monolithic architecture to a more service-oriented one, they also encountered issues related to the API, both when the need for new features appeared, but also when it came to working with different platforms, especially in the mobile side. And you will see that this is a very important one, because they ended up having pretty much the same problems that Netflix presented, especially in the area of requesting every time data in a specific format, depending on the kind of device that they had to take care. So they come to some actions like, okay, let's rewrite some parts and re-estimate and try to plan again and things like that. So the solution was, again, and it will sound very similar, they decided that each use case would get its own API server. So each type of client will get something very specific. So in this way, developers had the freedom to optimize specific use cases without needing to worry about the other cases that they are using. The name of this pattern, of course, as we've just said, is the Backend-For-Frontend pattern. It's easy at first sight to think about best friends forever. Well, seems like using this pattern really helps creating a friendship between frontend and backend, because the goal of this pattern is to decouple the frontend apps from the backend architecture. The BFF it's all about building a layer that satisfies the exact needs of a specific client. A very specific advantage of this pattern is the reusability of code, because all the clients have the possibility to fetch data from the same BFF server, creating a cache. So they are making the process less complex and the client less chatty. Let's look a bit at the traditional front-end and back-end separation application. If we are taking a more specific case, we are going to be able actually to build a case on the point. The issue about this is the number of requests that, since the services are creating in a very generic way, have to fit and be more open to needs. Thing that gets us to actually giving bloated results and receive data that we don't need. Either too much data on the front end and doing some workarounds on UI that usually create a lot of issues. So in order to minimize the number of requests and give the proper payload, it means that sometimes the backend will do some UI related specific processing to meet the needs of the client. So one way or another, we end up talking about in which camp we throw the fireball. The biggest difference in front-end for back-end architecture is that the front-end no longer directly accesses the generic backend, as you can see. Now the access is made through the BFF, which is a middle layer. This way, each client will have a BFF service. This way, we are doing some processing at the BFF level for the UI logic and result in fewer mutual calls between the different services. Well, as we can state, each client is being satisfied in its specific requirements. This thing wouldn't be possible, or at least not easily done, for a specific service that returns specific data on the API. What for one client might seem like the perfect set of data, for another client consuming the same API, that might not seem the perfect solution. It might seem maybe overfilled or fat payloads that we were talking about. If we move the discussion thinking about the mobile client, things become even more sensitive. Using the same load from a web without without really needing everything from it represent most of the time a trade-off in latency, especially since we can't control the power of the network our application is going to be used on. So we go down to the BFF pattern. This way each client will have a BFF service, and as a result all the processing will be made at the BFF level. So from the before understanding of BFF, and since the BFF is a middle service accessed by front-end and back-end, what is the difference between BFF and an API gateway, you will think? And we will answer this. But before I really want to just go through the things that it brings to the table that are very important. Providing only the data the client needs. We already talked about this, yeah, because we are doing that aggregation in the middle layer. That is the main purpose, actually. Yeah, no more nor less. Then, less response time. Less response time truly depends upon the technology, indeed, and also on the right approach that we are using. The right approach, when I'm talking about right approach, I'm talking about one that is specific for our needs, not something that it was right for another person. This can be done calling other services and some other slicing or dicing up. We have to be very careful about how we do managing that. It should be resilient by design. Yeah, so when we are talking about an API like this, because it is a single point of failure. We are creating somehow a single point of failure. So it has to be very carefully load tested. If one or more services is taking too much, then it is okay to just return a partial result. And the caching part, yeah, we have to do this in a very organized manner in order to not again end up with the data that we need or data that is not we don't need, or data that is not updated. So we have in here a display of the API gateway. In this case, API gateway does not distinguish between client types as shown below. So it is just your natural, you have services, they are just going through the API gateway and served to the mobile or web, but nothing is done in between, or only they are publishing there and managed from there, but not actually using the aggregation layer. In this one, we can have a case where the API gateway determines which client it comes from based on different APIs and makes some processes that handles them separately somehow in order to actually return the requested resource corresponding to the client that is asking. The last and maybe more similar to a BFF approach is, and this is actually considered something like a BFF approach with some changes, because you also have a single point of failure. It's a bit hard to maintain, especially if it's a third party, so you are using and trying to actually become compliant with something that is not in your control, so it might be a third party. And it's hard to actually see, okay, who manages this? Is the backend, because this is a server, and you cannot, the client is not really writing something, it's just orchestrating some services and sending them where they have to be. So it's a bit tricky about us, because we are not giving that control on the client side as we discussed and as we were saying. Of course, everything that we've discussed and we are going to discuss today has costs if used in the wrong context or in a very wrong way. And when it comes to BFF, there are also some concerns. There exists a probability that each BFF might implement similar capabilities, but different teams, so it's very hard to actually know at the same time and do a plan about it. So this might lead to doubling the cost of development, but the benefit or the bright side is that we can identify this application in the place that it appears, and consider this the opportunity to actually create one or more, why not, shared libraries to get certain functionalities developed only once and used in several places. So with a bit of care to best practices and actually create a mindset globally, we can go over this, and we might get more services and components, but as we have to structure the backends for each specific front end, and the number of deployable units, of course, it increases. But this doesn't mean that we can't have control, because with a great DevOps team, with a great attention to details, to monitoring, to automation, and with extreme ownership around quality, we can also go over this. And when it comes to the complexity, you already talked that we have to be very careful, because we are talking about a single point of failure, a middle layer that it's very, it has to be discussed from the beginning, very clear who owns it and who has to maintain it. Going further to GraphQL, let's see how it fits. So from what we've discussed until now, each BFF can help us in situations where we have to handle one specific case or similar specific cases. In fact, that allows us to create API that gives us the freedom to manage them in a way that avoids the situation of that one-size-fits-all API. While this approach gives us some modularity, we need to be aware that there are still some points that need to be paid special attention, in the idea that the contract between the client side and the server side is fixed. So in order to loosen up these interactions and dependencies, a cleaner way to serve clients would be to call GraphQL to the rescue. A bit of context on GraphQL for the ones that haven't used it or haven't heard about it. It was created at the Facebook, thinking about a way to reorganize the way it worked with APIs. So basically, again, we meet the frustration we talked already related to the differences between the data received and the use cases from the interface. Very important about GraphQL is that they said from the beginning that it's not a library, it's not a product, it's not a database, it's a specification. Very important, because you will find why on the game. Long story short, GraphQL provides a declarative way for the UIs to interact with specific data they need. So specific data, again, we are talking about the same thing that actually hurts. So data shaped by some resolvers. The UI just specifies what it needs with queries. And since we're talking about queries, when we talk about GraphQL, we talk about the query language on one side and the schema language. The cool thing about the query language is the fact that it's allowing you to fetch just the data you need in a friendly and efficient way. And coming to complete this context is also the schema language, where we can define and actually we can see what queries or mutations we can access, so what operations we can do in order to receive or send the data that we need, and only the data that we need. Just a bit of context about how a query might look, or how a type is defined, but about the details related to the representation and how it can be used, you can find documentation and take a look on it. Because what I want is that I want to go beyond the capabilities at the implementation level, and I would like to discuss the points where it shines when it comes to architecture. So you're more than welcome to welcome to go and see exactly what it is doing in the implementation level on your own, and see how it fits your project or your context. Of course, we have, because okay, it's GraphQL, but why GraphQL? We have REST, right? And of course, it's not a debate between which one is better, but more like a matter of selection of the right tool for the right job. While GraphQL APIs help avoid both underfetching and overfetching, and provide built-in data validation, among other things, REST has been around forever and has a super high adoption rate with well-known conventions. So pretty much you have to just understand exactly what are the higher level differences between them, and then just decide, okay, what do I want? So on one side we have GraphQL with specific requests, specific response. Then we have the lack of endpoints, so resources declaring their own. In GraphQL we all have only one endpoint, and REST we have a lot of endpoints. In this case, GraphQL reduces the number of API calls. REST requires multiple calls for nested complex data, while GraphQL calls once, reducing the network overhead. So it's very important. Error code processing. REST can indeed return a very accurate HTTP error code. GraphQL, on the other side, returns a 200 and wraps error information for what is actually happening in there. And in GraphQL, we don't have the versioning issue or overhead, because GraphQL is implemented through the schema version, and we are just the schema extension. We are extending that schema with the data that we need, or the processes that we need. In REST, we had to implement the versioning. You know the story. A bit of parallel, the endpoints and how they are related in the REST API, and how generally, of course, there can be a lot of operation that can be done. This is a general implementation and general, let's say, representation of the concepts. So we are not saying that one or another is bad. We are just looking at them from somewhere above in order to see exactly what it goes with what. I really liked this thing, this representation, because somehow it's real. To be fair, REST is the data fetching equivalent of going to a restaurant and being asked what you want will give you what we need. One of the biggest drawbacks of REST APIs is that they don't have a schema describing what the data structures are returned by the API endpoints. So let's imagine I have this REST endpoint with a GET request, and I just see it, okay, it's, let's say, participants, okay, but what else? The only thing that I can do that's closest to the reality is just imagine what exactly it will return. It will be a list of participants with some info about the participant. But just by looking at the endpoint, I can be sure what I'm working with. GraphQL has the schema serving as a contract, defines and displays very clearly the shape of the data that can be requested. And this operation specifically is named introspection. But I was talking about where GraphQL really shines, because the very nice part is that, indeed, as we discussed, since we can create the queries the way we want them, with the relationships that are defined, the client gets more freedom respecting the data that it gets. So this is something that I guess we can all agree. Then the possibility to serve several clients. GraphQL does not need dedicated endpoints. We have everything defined in a graph that we query to the query language. While I have the system exposed with all the capabilities, I'm just fine. Makes it easy for different clients to coexist and evolve. Well, if we just go 10 minutes back at what we discussed, both Netflix and SoundCloud created BFFs that were able to serve different clients in a specific way without interfering with the development experience on the backend. Well, GraphQL does that also to the specification. The backend can add new functionalities without the client needing to know about them. In the end, through the introspection that we just discussed, the client can see what it can or can't call, or what are the operations that are available. But how about when I have a complex system with a lot of REST services in place, or so-called REST APIs, used by several clients, and I don't have the time or the resources to change them all. And at the same time, I really want to optimize the data that I'm retrieving. Can I get the best of both worlds? Like create a BFF, do something with GraphQL? Well, we can try. We can try to create a BFF that actually it's using GraphQL management of data. Of course, it implies everything that we've just discussed, but basically the client dictates in this specific case the way the response should look like. Queries the server as precisely as possible. The server resolves the queries and returns the requested data to the client, to the specific client that it has to use it. Of course, we have to be very careful about the issues that we might think that are not gone. So first, it would be very careful to the way you fragment your data, because indeed GraphQL, it was thought of as a way to actually get away with this problem, the N+1 calls, that we have in the REST API. But we have to be very careful about the requests, about what the request is retrieving in order to render a particular page. Then we have to be very careful about how much we build the APIs with the UI in mind. Because the BFF allows your backend developers to build the APIs that make sense. It should still absorb the complexity as a good API will, but they do not need to build it with one specific UI in mind. So it's very important to actually be careful about not doing it too much client-specific. See? It's very important to look at your use case and see exactly what it goes very well with it. Because having thought about this for a long time and having a lot of issues on the matter, I've reached the following conclusion. Front-end developers need to build their own backends, or at least have control. So I would say that in order to do that, there are some changes in the mindset are needed. First, quit associating the front-end and backend with client and server. If you want to work with a BFF and get the best of this, you have to think of the backend as more of an extension of the front-end. Create an overview. You don't need to be the master of the whole stack. It should be good to have an overview on more than just the front-end or the back-end side of the application in order to where you are working. Having context, having an overview gives you a better perspective on what exactly you can create and how the two interact and work. And this helps you a lot on optimizing and creating stronger, maintainable, and yes, user-friendly application while still satisfying the business requirements. And also a very good thing to do would have, in this case that we talked, to have also the front-end developers work on the GraphQL server if you go in an approach like this. And third, and last, work on the communication to backend developers. Now that we know who says what behind each other's back, we can understand that on both sides the pressure is huge. So we have to look at the application as a whole, and not only considering the backend or the frontend, our very strong baby, but more like let go of this limitation and adapt to the needs. So keep an open mind, people. And I really hope that my words today marked an interest point and that your curiosity was triggered in order to dig more on the matter and maybe pay more attention to the subject. Whatsoever, I want to leave you with this thought. There is no silver bullet or a golden hammer. What works well in one project can be pretty damaging in another one if used mechanically and without prior research. As someone was saying, and I really liked this way expressing, there is some inherent complexity in software development and no magic tool will remove it. And this is so relatable. So choose wisely, research, and go with a choice that gives you the smallest cost and the biggest win. Thank you very much for listening to me, and I'm looking forward to the discussions and the Q&A part. Thank you.